content in this presentation aligns with pages 84 through 87 of your textbook, and it's meant to help you achieve Learning Objective 16, which is to explain how different types of thermometers work, and why the placement of thermometers is an important factor in obtaining accurate readings. If you haven't already done this, it's a good idea to skim pages 84 through 87 before you watch the video, paying particular attention to the bold words and to the figures in their captions. Please plan to read the content more thoroughly before you attempt the online quizzes. During a typical day, many of us check the air temperature multiple times. If you listen to the radio, you're frequently hearing the temperature announced. You might even see them in different businesses, and especially banks in the area seem to show you what the temperature is. I don't know what that connection is. Many cars show the air temperature as part of the dashboard display. And that's sort of an interesting thing in the context of this chapter. I'll share with you and hold my feet to the fire on this. Don't let me forget to bring it up in class. But what is the most dangerous weather condition in Washington State? It's related to temperature, and it's related to things we've already talked about. So bring that an answer to that question to class. Maybe I'll poll everybody as soon as we get started. Thermometers are meters of therms. So they measure the temperature of something. Thermometers measure temperature either mechanically or electrically. Mechanical thermometers measure the expansion and contraction of molecules. Most substances expand when they're heated and contract when they cool. Many common thermometers operate using that property. More precisely, they rely on the fact that different substances react to temperature changes differently. The liquid in glass thermometer shown on the right of the slide here is a simple instrument that provides relatively accurate readings over a wide temperature range. Its design is virtually unchanged since it was developed in the late 1600s. When temperature rises, the molecules of fluid grow more active and spread out, so the fluid expands. Expansion of that fluid in the bulb is much greater than the expansion of the molecules of the enclosing glass. And as a consequence, a thin thread of fluid is forced up the capillary tube. Conversely, when temperature falls, the liquid contracts and the thread of the fluid moves back down the tube towards the bulb. The movement at the end of the thread, which is known as the meniscus, is calibrated against an established scale to indicate the temperature. So the highest and lowest temperatures that occur each day are of considerable importance and are often obtained by using specifically designed liquid and glass thermometers. Mercury is the liquid used in the maximum thermometer, the one here up at the top with the gray fluid in it. You can identify the maximum thermometer because it has this constriction in the tube. So you can see this place where it gets really skinny. As the temperature rises, the mercury expands, and it's forced through that constriction. When the temperature falls, the constriction prevents a return of mercury into the bulb. So as a result, the top of the mercury column remains at the highest point. So that's the maximum temperature attained during the measurement period. And then you reset it by shaking it to force the mercury back down through the constriction into the bulb. So once it's reset, the thermometer indicates the current air temperature. In contrast to a maximum thermometer that contains mercury, a minimum thermometer contains a liquid of low density fluid, like alcohol. Within the alcohol, and resting at the top of the column, is a small dumbbell-shaped apparatus known as the index. As the air temperature drops, the column shortens, and the index is pulled toward the bulb by the effect of surface tension with the meniscus. When the temperature subsequently rises, the alcohol flows past the index, leaving it at the lowest temperature reached. To return the index to the top of the alcohol column, the thermometer is simply tilted. Because the index is free to move, the minimum thermometer must be mounted horizontally, so side to side, otherwise the index consistently falls to the bottom. Another commonly used mechanical thermometer is the bimetal strip. As the name indicates, that thermometer consists of two thin strips of metal bonded together, which have widely different expansion properties. So when the temperature changes, both metals expand or contract, but they do so unequally, causing the strips to curl. This change corresponds to the change in temperature. The primary meteorological use of the bimetal strip is in the construction of a thermograph, and that's an instrument that continuously records temperature. The changes in the curvature of the strip can be used to move a pen arm that records the temperature on a calibrated chart that's attached to a clock-driven rotating drum. Although very convenient, thermograph records are generally less accurate than readings obtained from a mercury and glass thermometer. So to obtain the most reliable values, you have to check and correct the thermograph periodically by comparing it with an accurate, similarly exposed thermometer. So they're kind of deployed side by side. Some thermometers don't rely on differential expansion at all, but instead they measure the temperature electrically. In this case, a resistor is a small electronic part that resists the flow of electrical current. So a thermistor is a thermal resistor, and it's similar, but its resistance to current flow varies with temperature. As temperature increases, so does the resistance of the thermistor, reducing the flow of the current. As the temperature drops, so does the resistance of the thermistor, allowing more current to flow. The current operates a meter or digital display that is calibrated in degrees of temperature. So the thermistor is used as a temperature sensor, basically an electrical thermometer. Thermistors are rapid response instruments that quickly register temperature changes. So they're commonly used in radiosondes, where rapid temperature changes are often encountered. The National Weather Service also uses thermistor systems for ground level readings. A sensor is mounted inside a shield made of louvered plastic rings, like the one you see here. And a digital readout is placed indoors somewhere. So if you see one of these apparatuses attached to a building, someone inside can read the digital temperature. It's also a more effective tool for measuring temperature remotely, so places where you won't be every day, such as at the Snowtel stations on mountaintops throughout the western states. The picture you see on the left is the Mount Eac Snowtel site above the coastal town of Cordova, Alaska. Use the content on the Canvas site as well as outside internet sources to verify that you can formulate answers to these questions. If you can comfortably answer these questions, you're in great shape for the midterm. If you can't, review the textbook, rewatch the video, and see if that helps. If you're still completely stumped, start a discussion on the Canvas site or ask for help.